So welcome to Julia and James, and over to you for your intros and presentation.
Yes, okay, so James is going to do most of the talk, and I really just wanted to thank Barry for spurring us into doing this, because it's been really interesting to, we've done a few talks a few years ago, and it's been really interesting sort of updating things and having a look to see how things are progressing. So it's been good fun. Thank you. Over to James.
Right, I'll see if I can.
He's trying to operate it from his phone.
Oh, yeah, it's working. Okay, so I'm going to talk a little bit about science from the Intergovernmental Panel on Climate Change and the latest report, and also go beyond that and talk a little bit about solutions to climate change and how to deal with it. I'll start off with very little about us, as you suggested. We are two climate scientists, worked in fairly conventional positions in the UK and Japan for about 20 years, and produced and published papers and contributing to the IPCC reports in 2007 and 2013. And then after we left Japan in 2013 and came back here to work, do our own work, enjoying the blue skies around Settle and the views over the Pen y Ghent and the sheep and things. But we still kept on working while we were here. And most recent bit of work, if you read Science magazine, which of course you don't, we contributed to rather a large piece of work, 100 pages with about 30 authors. And one, we were noted as runner-up in the Science magazine's Breakthrough of the Year. They do an annual review of all the science that's happened in the past year. Last year, unfortunately, the COVID vaccine came out, so we didn't get to win. We were only a runner-up. But this big paper, which was based on something we did 15 years ago, really, was quite heavily referred to in the IPCC report, which has just come out. If you want to see the paper, it's the Science magazine's article about it, and there at the bottom is the reference. And it's actually free to download. It's only 92 pages, I just checked. And there are names somewhere on the authors list there. So that's the sort of thing. So we're still engaged in climate research, even though we're just living in Settle. So climate change research and the IPCC. I should mention what IPCC actually is. It is the Intergovernmental Panel on Climate Change. It produces reviews of the scientific literature about every 6 years or so. And it produces these 3 reports, which are called Working Group 1, the physical science basis. Working Group 2 is talking about the impacts of so Working Group 1 is talking about the science of climate change, the physical science, how the climate system works and how we're changing it. Working Group 2 is talking about the impacts that has on human society. And Working Group 3 is talking about what we can do to reduce climate change, to try to mitigate, to try to reduce our emissions, essentially, reduce climate change. The one that came out this year is just Working Group 1, which comes out first. This is the one that's just been published and is the main scientific information available to COP26 on how the climate system is changing. And that's the one we are most heavily involved in the creation of. So a few summary pictures from this new report. On the left here, we have the last 2,000 years global mean temperature, and you can see it's sort of fairly stable, slightly declining, in fact, from about 1,000 years ago, and then suddenly shooting up in the last 150 years. On the right, we have a zoom up of the last 150 years alone. And the green bit here, these are model simulations. Well, sorry, the black wiggly line here is the observed temperature change. The green is what the climate models simulate if we only put in natural factors such as volcanic eruptions, which cause these dips, and differences in solar output. And it stays fairly level, slightly declining even. And the brown is what happens if we include CO2 and methane and other greenhouse gases as well, and land exchange as well as the natural forcings. And you can see that we still have these dips with the volcanoes, but the agreement is fairly is fairly good. This is one of the pieces of evidence that leads us to conclude that we are indeed changing the climate and we're responsible for this warming that you can see in the last 50, 70 years or so. It's not by any means the only bit of evidence, but it's one of them. So the IPCC also looks onto the future. Can you get me some water, please, Jules?
Yeah.
Thanks. So the IPCC also predicts future climate changes. Here we have several scenarios that they've produced as possible ways in which society may produce greenhouse gas emissions. And we range from scenarios in which gas emissions reduce fairly rapidly, go down to zero, even below zero by the end of the century, i.e. we're taking CO2 out of the atmosphere more than we put in. Other scenarios where it's sort of levelish and something goes up more steeply or less steeply. These then feed through into predictions of temperature change according to all these. Again, we have the historical bit, the grey here, the black and the grey, the historical simulation, and then the future. And one point to note is that even if the greenhouse gas emissions go down fairly rapidly, the temperature continues to rise for a bit. In fact, none of these scenarios stay below 1.5 degrees. And these, even these optimistic ones where greenhouse gases are already going down, the temperature rise gets above 1.5 degrees, close to 2. You can also note here that these scenarios, optimistic scenarios, suggest greenhouse gas emissions are already flat or declining even past 2015. So they created these scenarios starting in 2015. Of course, they did them a few years ago. As well as temperature change, we've got changes in things like sea ice. You can see there in all of these scenarios, the sea ice continues to decline really quite markedly. And look at that cat. And sea level rise continues as well. This is sea level rise on the right. Point is that we actually emitted a lot more sea level rise. So the sea level rise we've already got to here is a fairly modest level of about 30 centimeters. And even under the optimistic scenario where the greenhouse gas emissions went down a lot very rapidly, we still get probably about a meter or so of quite a large uncertainty here, 1 meter to 2 meters, 3 meters even, sea level rise by 2300. So essentially the sea level is going to continue to rise a lot if we do cut our greenhouse gas emissions. Some points made in the report. We have more confidence. Essentially, there's not a great deal of change actually in terms of the overall picture of how climate is changing. We're a bit more confident about things that we thought were happening. For instance, there's more variability, as well as warming, there's more variability, so there's going to be more extremes of both heat and not so much cold, but all sorts of different sort of extremes like flooding. And impactful climate events are more likely to happen close together. But the picture hasn't changed a great deal. And it goes beyond purely things that we think of as climate as well. For instance, we have ocean acidification, which is going to increase, which is going to continue increasing for a while as the oceans obviously uptake the CO2 from the atmosphere. So this could put the base of the ocean food chain. It's important for plankton, essentially. Some of them grow with, they produce calcium carbonate. They use calcium carbonate as their shells, and it basically dissolves that and makes it difficult for them to grow. So this does threaten some of the ocean food chain. So in summary of the science, we're changing the climate. The future changes will be larger. The climate changes are definitely large compared to historical past. And a point that I put in, because I heard actually from a friend of mine who's a university professor, who said that he was surprised to find out that when he's teaching his students about climate change, they didn't actually really quite realize that we'll keep on warming not just until we cut emissions, but until we actually stop completely and get to zero. As you keep on putting CO2 into the atmosphere, the world will basically keep on getting warmer. You can quibble about the last 5% maybe, or 10%, but you know, reducing emissions by 20, 30, 40, 50% doesn't stop the warming at all, it slows it down. You have to really get down to 90% basically before you can really stop it. We're now on the question of what we can and what we are doing about it. And this is where we go a little bit beyond purely questions of science. And science tells us how things are and how things will change. What we ought to do about it is really a matter of ethics and politics and justice. It's not really just a purely scientific question. The idea of following the science that we've heard a lot of recently related to COVID is completely misrepresents what the situation is. The science doesn't tell you what the answer is at all. It only tells you how the tools will or won't work. Climate change has many aspects, and I do highly recommend this report, which came out a few years ago now, called The 7 Dimensions of Climate Change, came out of the USA. Jonathan Rowson was the main author there. Just describing how climate change affects has many different aspects. The science is only one part of this whole problem, and it really takes a much broader approach to deal with. It's fundamentally a question of how we supply energy, of course, and energy needs to be affordable, secure, and carbon-free in order to address climate change. And it's worth noting that this is not just an environmental issue, and indeed, it may conflict with various environmental issues. I mean, wind farms have environmental impacts. They may be good in terms of carbon, but they have impacts in terms of where they're sited. And the same goes for the toxicity of manufacturing batteries and solar panels and dealing with them. So to some extent, solutions that work for the climate alone, they have other environmental impacts. You need to take account of all these things. We had a quick look at what COP 2019, the last COP meeting, talked about, and essentially they agreed that they should be aiming to stop global warming below 2 degrees, but they didn't really come up with sufficient targets to do this. And I think it's worth pointing out that really staying below 2 degrees is a really big target. Certainly, 1.5 degrees is pretty much out of the question. We're not really going to stop global warming that quickly. It's not. None of the countries are really promising action that's sufficient to do this. They're only promising action to slow down global warming, not really to stop it. But there's also people talk about this 1.5 degrees thing. This is an article I wrote a couple of years ago, actually. Some quotes from an article, sorry about the small text and everything. Some quotes from an article I wrote a couple of years ago looking into this thing about the threshold of 1.5 degrees being dangerous and we have to stop global warming. I mean, Greta Thunberg a few years ago said that, we're going to set off a chain reaction that will lead to the end of our civilization as we know it. I think she said this to the British Parliament, actually, in 2019, possibly. But the IPCC really, I mean, there are some scientists who present these sort of statements, but really this is not what the scientific consensus is at all. The IPCC quite clearly summarized that there is no evidence for this sort of tipping point threshold thing. And as Miles Allen, one of the authors, says, there is no real threshold below which everything's okay and above which everything is terrible. It just gets gradually worse. The more we emit, the more we emit, the worse the problem is, and the more warming we get, the more damage there is. And it's a very incremental and gradual process. There's not really a threshold at which things get terrible or okay. One of the problems I have with this sort of idea about thresholds and deadlines is that what happens when you go past them? And those with long memories might remember this organization, the New Economics Foundation set up this organization, 100months.org, with a website saying we had 100 months to save the climate, to save the planet. I had to find this. This is a screenshot out of the Internet Archive, because this website was set up in 2008 when they said we had 100 months to save the planet. And of course, we're now 150 months past that and the website's been taken down. So if you believe that, then well, you know, we're already all doomed. But actually, I don't believe it's really a very, very, very productive approach to take, because it leads to people getting unnecessarily pessimistic. I did a few quick calculations as part of that article I wrote. I'm going to skip this because, well, I did a simple calculation showing that the effect of delaying. All right, so I'll just compare these two lines here. I've got these are three scenarios here where we decarbonize the economy at a 2% per annum rate, but we either start it in 2020 or 2030 or 2070. So the effect of these three different starting times, you feed this through, this is the emissions, you feed this through into concentrations in the atmosphere. You notice how the concentrations keep on going up even after we start decarbonizing, because we're still emitting, it's just we're emitting a bit less. And on the right, we have the resulting temperature change, observations here matching the model very well, or the model matching the observations, I should say. So the effect of delaying by 10 years here is 1/4 of a degree. So this is how I get this statement saying that it's about 0.02 to 0.03 degrees of warming, extra warming per year of delay of all the action we take. So this is something that should give us some impetus to act with some urgency, but not with any feeling of a particular deadline or threshold. It just gets worse. The longer we delay, the worse it gets. Okay, looking at the global picture for what the emissions have been over the last 20 years, we have just a few select countries here, and you see the UK is the third line down here, this sort of reddish colour, and the UK's emissions have been declining over the last 20 years quite significantly. So is Germany, so is the USA from a higher starting level. China's going up. The global mean is actually fairly flat in terms of per capita emissions, about 5 tonnes. Down here we have some very high population but low emission areas. Conclusion we can draw from this is if the rest of the world develops like the West, then we're in big trouble, because those emissions will go up by a factor of 2 or 3, which means the global average will go up a lot. They need to develop in a direction that does not involve large-scale fossil fuel burning that we've done in the past. The UK's decline is very impressive, actually. 44% reduction in CO2 emissions in the last 20 years. That's 3% a year, which is a really good rate. However, a lot of this has been fueled by switching from coal to gas. And although that leads to a step change, it leads to a big reduction in CO2 emissions. It doesn't go on forever, because gas is still a fossil fuel, and it reduces our emissions by a factor of 2 maybe. But then getting beyond that takes new technologies and new ideas.
And we don't know what they are.
Well, we do more or less know what they are. We've got to do them. Here's wind and solar costs, how they've changed over the last 15 years or so. These are American numbers, so they're all in dollars. You can see that they've all gone down a lot. You've got wind on the left and solar on the right. They've gone down a lot, though there's evidence that they may be flattening off a bit. And this is how the cost of solar wind compares to conventional gas and coal. I've labeled a few of the specific things there. The top rather expensive solar one, this is for personal, the personal solar panel on your roof. This is for a utility that's got a large area of land, and you've got a big economy of scale here. What the numbers actually mean here, the numbers are per megawatt hour, so that's 1,000 units. So essentially this is talking about a cost of about 15 to 20 cents per unit, and this is about 4 to 6 cents per unit, coming in competitive with gas roughly. This is from 2016, and as Julia said, we've been, this is actually a picture I showed a few years ago. Updating it now with the new numbers, you see that now the utility scale solar is actually coming in undercutting wind, undercutting gas. So we really are at a point at which these low carbon alternatives really are competitive and are starting to take over. This also is a plot I showed a while back. This is showing how the China total capacity of China has increased up to 2016. Redoing that plot now, and There you go. So that big bar, the biggest orange bar there, is now this one, and it's gone up by a factor of 3 or more since then. So it's still continuing on this very impressive exponential growth. It's still too small, but it is improving. It is increasing a lot. And here's the picture for the whole world, where you see a lot of countries and the world as a whole, solar energy capacity has increased very radically. The UK is the one just above Africa, if you can see here. And the UK has actually been flatlining recently. Africa's catching up. The UK is not actually going down. It looks like it's getting closer to Africa, but Africa's going up. While a lot of Europe and Western countries have been doing quite well, the UK has been stalling. This is a larger scale plot of the total solar deployment. And what happened is we had this very rapid period of very impressive growth. And then they cut the feed-in tariff. And of course, everybody said this is going to kill the solar industry in the UK. And sure enough, it has. There's been essentially very little growth since the big feed-in tariffs were finally cut about 5 years ago. So this is an example of political decisions feeding through into how the economy, how society reacts. So finally, to summarize what we can do about this. One thing we can do, I think, is try to be positive. The world is changing, and we can't just say we can't do X, Y, Z. We can't burn fossil fuels. We have to provide solutions to what people should do and must do instead. There's a whole lot of actions we can take on a local, personal level, as well as pushing for political solutions. Things like insulating our houses. Actually, I'll just show this picture now. Yeah. Here's an interesting, I don't quite know the validity of this. It was a survey done by a company, but this is showing the amount of energy lost by houses across Europe, and the UK is really quite spectacularly bad compared to the European average. And this is, of course, because a lot of our housing stock is old. Even some of our new housing stock is quite low quality as well. But that's one of the issues of reducing our carbon consumption. We can do things like getting solar panels. Talk to Barry. He's not the only one, but he's just next door to us, and he's got his solar panels on. And buy less stuff. Do more e-driving rather than driving and cycling. On the subject of e-cars, this is how the number of electric cars in the UK have increased over the last 3 years. That little green band up there is a few percent of battery cars, and there are also some hybrids there. So this is it's increasing. It's not hugely impressive. This is a comparison. This is how Norway is going, and Norway is now at the stage at which basically it's gone to electric. Happened, and it's happened all in a space of about 10 years. So looking back 10 years, they were where we are, and the government's plan is that we should basically be electric in 10 years. So I think this looks quite achievable, that we really can do this and can switch over on this timescale. I've covered up my text, but just to go back to it, there you go. You can do things like somebody's already talked about population, having fewer grandchildren or children, eating less meat, and of course voting, but make sure you vote the right way. And I think that's the end. Thank you for listening.
25 minutes.
Thank you very, very much. I'm glad you enjoyed kind of updating your previous presentations. You've obviously condensed tremendous amount to give us some very clear illustrations of where we are, where we might be going, and some of the data behind it. So that's much appreciated.